Hello, I'm David Krebs, and in this video we will learn a skill called factoring a quadratic polynomial into a product of binomials. Then we'll explore one of its uses. In Alberta, this is part of the grade 11 curriculum. That's the Math 20 curriculum. A binomial is something with two terms, and product means multiply. We want to write that product as a quadratic polynomial. Here's an example. Okay, let's do 2x plus 3, that's a binomial, two terms, times 3x plus 5, that's another binomial. And we're going to think of this product as the area of a rectangle. Okay, so this area is going, this rectangle will have height 2x plus 3, right? So this length of 2x plus this length of 3 is 2x plus 3, and that's equal to the height of the rectangle. And then on the top, the width we'll make to be 3x plus 5. So the entire width is 3x plus 5. And so now this product, the height times the width, as you recall, is the area of the rectangle. But there's another way of writing this area. We can think of the area as the sum of the areas of the four smaller rectangles. So let's take the area of each of those four smaller rectangles and see what it has to be. So 2x times 3x is 6x squared. 2x times 5 is 10x. 3 times 3x is 9x, and finally 3 times 5 is 15. So this is the sum of these four. So 6x squared plus 10x plus 9x plus 15. Okay. And now we can write this as by collecting like terms, we can write this as 6x squared plus, well, 10x plus 9x is 19x. So collecting those like terms, we get 19x plus 15. Now, if x, or some of these numbers out here, were negative, then these could no longer be called lengths and areas. Height and width are lengths, and so must be non-negative. However, thanks to the distributive law, it is still true. So this equation is still true, even if x is negative, or if some of these other numbers were negative, the schema would still work out. Students sometimes know this as the FOIL rule. First, outer, inner, and last. So the quadratic polynomial here is factorized as 2x plus 3 times 3x plus 5. Now let's go in the other direction. So example, so factorize x squared plus 5x plus 6. So again, we'll bring up our rectangle. Okay, so we've got stuff now inside the rectangle. So x squared and 6. And then these numbers in the blanks have to add up to 5. Just like they did before. Numbers in the blanks have to add up to this middle number here. So x squared is just x times x. There's really only one way of factorizing x squared. And now, if we look at this here, we just have a blank there and a blank there. But actually, this blank is the same as this blank, because when we multiply this by this, we get this. So this is the x, and this is this blank. Similarly, this blank here is the same as this blank here. And we know the product of those two. We know the product of this times this is 6. So we look at these two numbers here. Their product is 6 and their sum is 5. So let's write that down. So sum equals 5 and product equals 6. Just looking at these two numbers here. Their sum is 5 and their product is 6. So you might want to pause the video for a moment just to figure out what these numbers might be. But turns out, a little trial and error, you can see that two numbers that work are 2 and 3. Okay, so this is equal to x plus blank times x plus blank, and we know what those two numbers are because we've figured them out, 2 and 3. So x plus 2 times x plus 3. So x plus 2 times x plus 3. Here's another example. Here's another example. Let's do 6x squared minus 13x minus 5. Okay, and again we'll bring up our rectangle. Okay, so 6x squared, 6x squared, and minus 5, and now these two numbers in the blanks have to add up to minus 13. Okay. Now 6 factorizes in various ways. So 2 times 3, 1 times 6. So we don't know exactly how we'll be factorizing that 6x squared there. So we have to put blanks in front of the x's. And then here we have blank and blank, just like we did before. Now we've got 4 blanks to fill in around the outside rather than just 2. So as you might imagine, it's a little bit more involved. Now, these two numbers once again have to add up to minus 13, the two numbers in the blank. So the sum is minus 13. So this number plus this number gives you minus 13. Now, what about the product of these two numbers? Well, turns out that the product of these two numbers has to be the same as the product of these two numbers minus 5 and 6, which in this case is minus 30. So the product of these two numbers is the same as the product of these two numbers. You can go back to our previous two examples and check that. Actually, the reason it's true, if you want an actual reason, is that the product of these two numbers is actually the product of these 4 numbers around the outside. And actually the same thing with those. It's the product of those 4. So in this case, it's minus 30. So again, you might want to stop the video to think about what two numbers might have sum minus 13 and product minus 30. Okay, well, with a little bit of trial and error, these numbers that work are 2 and minus 15. Minus 15. Okay, so 2 and minus 15. Okay, so let's write that as 6x squared plus 2x minus 15x minus 5. Okay, and now we do a little bit of magic. We're going to put brackets around the first two numbers, the first two quantities, and around the last two. Okay. Now here you got 6x squared plus 2x. We're going to factorize as much as we can out of the front there. So 6 is 2 times 3. So we can pull a 2 out. We can't pull a 3 out because 2 is not a multiple of 3. So this is going to be just 2. And we can pull an x out, right? So we get 3x plus 1. Okay, so why 1? Well, because 2x is the same thing as 2x times 1. So we've just got a 1 left there. So plus, And then here we can pull out a minus 5. So we get a minus 5 times 3x plus 1. Okay. Now here the main operation is addition, and we're just adding this to this. And they have a common factor of 3x plus 1. So we can pull that common factor out. So we get 2x minus 5 times 3x plus 1. And you may be used to using a distributive law to factor out a factor on the left instead of on the right. We've taken this thing on the right and factored it out, but it doesn't matter. Multiplication is commutative. So for instance, 7 times 2 and 2 times 7, they're both the same thing. They're both 14. So we can do it on the right just as easily as doing it on the left. Okay. So what if we had used minus 15 and 2 instead of 2 and minus 15? So let's try that. So let's go 6x squared minus 15x plus 2x minus 5. Okay, and then we'll again do our grouping. So here we can pull out a 3, but 15 is odd. We can't pull a 2 out. So this is going to be 3, and we can also pull the x out. So 3x times 2x minus 5 is what's left. Plus, okay, plus, and now let's write this as 1 times 2x minus 5, because 1 is the multiplicative identity. So 1 times 2x minus 5. So here we get 3x plus 1 times 2x minus 5, which is the same answer. Okay? So it's the same answer. The factors are in a different order, but again, order doesn't matter when we're multiplying. Okay, so let's write this out then. So yeah, so let's fill in this rectangle right here. So this is going to be 2x minus 5 times 3x plus 1. Okay, so we're done. We factorized 6x squared minus 13x minus 5. Just to test your mastery of this skill, I'll give you now 3 exercises to work on. Okay, so there's some exercises to work on. And we'll go back at the end of the lesson and I'll show you what the answers are. What is all this good for? Well, one use is it allows us to solve quadratic identities. So a quadratic identity is an equation, also known as an identity, in one unknown, we'll call it x, that is quadratic, i.e. the highest power of x that appears is 2. So for example, given x squared, so given x squared minus 7x is equal to 6x plus 5 minus 5x squared. Find x. Okay, so we can simplify this by collecting like terms. So we can reduce the number of terms by collecting x squared and then pull the 5x squared to the other side. So then we get 6x squared minus 7x, but then the 6x we can pull to the other side, so we get minus 13x is equal to 5. So find x. Okay, now because x occurs in 2 places, the x squared term and the x term, we can't solve for x by performing ordinary arithmetic operations on both sides of the equation. Okay, because we have different terms involving x and they're not like terms. So we can't reduce the number of occurrences of x to just 1 by performing ordinary arithmetic operations on both sides of the equation. Instead, we will use our previous work together with something called the zero product property. Okay, so if we subtract 5 from both sides, then we get 6x squared minus 13x minus 5 equals, well, we're subtracting 5 from both sides. 5 minus 5 is 0, so we're left with 0 on the right-hand side. Now we can use our work before. This factorizes as 2x minus 5 times 3x plus 1, and we're told that that's 0. Now the zero product property says that AB equals, the equation AB equals 0 implies that either A is equal to 0 or B is equal to 0. Okay, so this is our A and this is our B. So we've got AB equals 0, so we can conclude that either A is 0, so 2x minus 5 equals 0, or 3x plus 1 equals 0. So in this case, 2x equals 5, or x is equal to 2.5. And solving this one, we get x is equal to negative 1/3. Okay? So this means that we have solved the quadratic identity. So if we plug in 2.5 in all of these 4 occurrences of x here, then we'll get that the left-hand side is equal to the right-hand side. Similarly, if we plug in negative 1/3, we get left-hand side equals right-hand side, and those are the only solutions. Those are the only values at x which work. Now, the number 0 here is very important. So what if we look at this equation right here and we say, okay, well, 6x squared minus 13x equals 5. So let's factorize the left-hand side. So we get x times 6x minus 13 equals 5. Certainly the same thing. All we've done is factored out an x on the left-hand side. Well, does this mean that either this is 5 or this is 5? No, the zero product property only works when you have a 0 all by itself on the one side. Not 5, 0. And also the conclusion is that a equals 0 or b equals 0. Not x equals 5 or 6x minus 13 equals 5. It's got to be 0. Now let's talk about something which doesn't factorize, about what quadratics don't factorize. Not every quadratic will factorize. So you may recall from the quadratic formula a quantity called the discriminant, we'll call it d, associated to a quadratic polynomial. D is the middle number squared minus 4 times the product of the outside numbers. Let's go back to our example in this case. Okay, so let's go back to that example we had right here. So D is equal to the middle number squared, so minus 13 squared minus 4 times the first number times the last number. So that works out to be 169 plus 120, which is equal to 289, which is greater than 0. So that's positive. The most important thing about the discriminant is its sign. In this case, the discriminant is positive and we can factorize. Of course, we knew that because we actually factorized it. Here's an example where we can't factorize. So here's an example. Just take 3x squared plus x plus 2. So the discriminant d is equal to the middle number. Well, what is the middle number? Well, x is the same thing as 1 times x. So the middle number is 1. So 1 squared minus 4 times the first number, 3, times the last number, 2. And that works out to be minus 23, which of course is negative. So in fact, this does not factorize. What goes wrong? Why can't we do what we did with the other quadratic polynomials? Okay, what if we try doing that same thing? So here we've got 3x squared. We got these numbers. And we got 2. And we're looking at those two numbers there. Well, their sum has to be 1, the middle number, and their product has to be 6. Okay? Well, turns out there's no such numbers. Okay? So it doesn't factorize. The equation 3x squared plus 1x plus 2 equals 0 has no solutions. Or, if you like, the parabola y equals 3x squared plus 1x plus 2 does not touch the x-axis. Let's do now, I'll give you the answers to those exercises that I promised you. Okay. There we go. So I'm David Krebs, and thank you for tuning in.